Hello everybody, and welcome to an introduction to Windows containers in Kubernetes. My name is Michael, and I am one of the co-chairs of the SIG special interest group in Kubernetes, and our SIG is designed to help accelerate, define, and deliver Windows container support in Kubernetes. I was actually one of the initial persons that founded the SIG a few years ago, and I've been a chair of the SIG since then, helping it traverse through the life cycle of Windows containers in Kubernetes. In my day job, I'm also a director of product management at VMware, and you can find me on the Kubernetes Slack account under the alias M2. So our agenda today is we're going to talk a little bit about where we are today, some of the continuous improvement that we've done as a SIG to kind of advance the vision of Windows containers in Kubernetes. We're going to do a quick deep dive on CSI and a high-level overview on Containerd, talk a little bit about perf updates and our future roadmap. I want to stress here that we have one more session on Windows containers that Maz, one of our key contributors on Containerd, and myself did. So I stress that you also follow that, because that presentation does a deep dive specifically around Containerd support. So if you're interested about Containerd and the effort that we're doing on improving the compute runtime for Windows containers, I highly encourage the session. Let's take a look at first on why do users and customers deploy Windows on Kubernetes. Our vision has always been to make Kubernetes truly ubiquitous and continue its lead as the top container orchestration platform. So our goal is kind of to enable users, operators, administrators to leverage the same operational efficiencies on Windows as they have today in Linux. That means the same knowledge, the same training that you have on Kubernetes applies on Windows. You get to have a scalable platform that can span multiple operating systems, both Linux and Windows. And most importantly, your developers are asking for a self-service, container as a service style platform. They want to take advantage of cloud-native tools, the new way of building, deploying applications, a new way of scaling applications. And Kubernetes delivers on that promise for both developers and operators. But at the key capability of Windows containers in Kubernetes is that you get to retain the benefits of application availability while decreasing cost. And that's super important in scenarios where you get to containerize existing or legacy .NET or Windows applications, because either you want to eliminate hardware or you want to eliminate underutilized servers. And most importantly, if you want to streamline the migration of applications from end-of-support operating systems into a newer operating system, Kubernetes, our Windows support, and the new way of building applications is really the right way to go. Think about this. You go from a different way of deploying and managing your applications to putting everything into a simple Docker file that you get to build and update over time. And through that Docker file, you have this programmatic way to define what should your application look like by modifying a few YAML files and JSON files. This is amazing. It's great to actually have that support. Let's take a look at first some things to consider, and then after that we're going to go into our roadmap here and where we've been. We want to make sure that everyone that's looking into Windows containers in Kubernetes, that they read the documentation. It's very important to understand the differences between Windows containers and Linux containers as it pertains to Kubernetes. As a special interest group, our goal has always been to make sure that we keep in lockstep all the features that are happening in Linux with Windows. That's not always easy. And it's very important to understand where there's differentiation, where the Windows community is ahead, and where it's behind on certain features. Second most important, you need to look at the fact that in Windows, unlike Linux containers, you have to enforce the host and guest compatibility. So the Windows Server kernel version, the major version, should match for now with the version of your guest container that's running on that host. So if you build it on Windows Server 2019, you must run the container on Windows Server 2019 host. And how you achieve that? By using node selectors. And we've added a new node selector called Windows Build that includes the Windows Build in it. You can use taints and tolerations. And as of the last couple of releases, you can leverage runtime class, which you can define once per cluster to simplify the steering of Windows or Linux pods to the appropriate nodes. And in the other presentation I mentioned earlier, we'll also talk about Hyper-V isolation. What's that going to look like? And it's coming soon. We're working on that actively right now as a SIG. The last part is resource consumption. Windows containers require higher limits and a higher memory, and they have a higher memory footprint because of Windows background services and other artifacts that are running inside the container. Kind of looking at our history, where we were and where we came from. When we started Windows containers back in 2016, we shipped the first release at the end of that year, 1.5. That was our alpha release. And essentially, we basically ported the kubelet and the kubeproxy to run on Windows. It was great work. It was very buggy. It had a lot of limitations, but it essentially showed the art of the possible to everyone and rallied the community to come in and contribute and make this a reality. With 1.9, a year later, we had our beta release. Tremendous updates. We had CNIs up and running, so lots of work came in from the community. And you're going to notice here the big circles include huge updates that we had. 1.14, we had our stable release. This was the first release where we had support for production workloads running Windows on Kubernetes. And we supported Windows Server 2019, which is the long-term servicing channel coming from Microsoft. Since then, there's been 4 more releases of Kubernetes, 1.15, 16, 17, and 18, where we've made advancements in kubeadm, CSI, run as username, and we took some of those advancements to beta as well as GA. In fact, with 1.18, we've made 2 significant advancements to GA, GMSA and run as username. And both of those capabilities enable Windows containers developers to define an identity that the container will carry on the network. Really critical part for running enterprise line of business applications on Windows in Kubernetes. We also took kubeadm to beta, cluster API to alpha, CSI proxy to alpha, containerd to alpha. 1.18 was probably our biggest release since 1.14. And then 1.19 came along. And now we have CSI proxy to beta. We have containerd to beta. We have networking enhancements like DSR and endpoint slices, and then additional stability and performance improvements. All right, let's talk a little bit about CSI and some of the updates to the work that happened in the community. If you're not familiar with CSI, it's really the standard for exposing block and file storage to containerized workloads on Kubernetes. And it's an out-of-tree provider model that enables CSI drivers and providers to operate and release independently of the core Kubernetes release cycle. And the way that it works from an architecture standpoint, it has a controller plugin and a node plugin. And the node plugin requires direct access to the host for making storage operations like calling block devices, file system calls. In Windows, the node plugin cannot operate as expected. And this is because on Windows containers, you don't have support for privileged containers, which is the containers that have a higher level of access on the node. And because this node plugin needs to run with these elevated privileges, we couldn't really follow the same architecture for CSI support as it exists today in Linux. So to solve that, we created a new component called CSI proxy. So it kind of bypasses that regular pipeline so that node plugins can now be deployed as unprivileged pods and then use the proxy to perform a lot of the privileged storage-related operations that are needed on the node. So it kind of allows us to bypass that existing mode of how CSI plugins work. So with 1.19, we are moving our CSI support and CSI proxy to beta. So we've had a tremendous amount of updates here. We've added support for API versioning, and we also version API groups to support disk, volume, SMB operations. You're going to notice iSCSI is not here because we're waiting for feedback from the community to see if we need to support iSCSI. We've added enhancements in kubelet, CSI node driver register, support for direct Win32 APIs, ioctls, and a lot of other things. And with this release, our CSI proxy beta will support two types of CSIs, Azure Disk and GC Disk, or the Google Persistent Disk Volume driver. What's next? We're going to continue innovating in this work. We plan to have a full CI/CD engine, as well as add additional CSI providers like vSphere, AWS, and so on and so forth. So if you're interested in that work, come and help us enable that. So now let's take a look at the CSI architecture diagram. Like I mentioned, you have Docker and kubelet and standard components in Kubernetes. And in order for some of the storage-related operations to be handled at the higher privilege that is required, we have this new component called the CSI proxy that is able to make the calls to the storage volumes, to the file system, to the file volumes on behalf of the CSI node pod. So in the CSI node pod, you have your node driver as well as a node plugin. Like I mentioned earlier, they're calling to the CSI proxy that bypasses and can proxy some of those requests down to the file systems. And then on the right side, you have your Windows pods, which have the different containers that can be attached to persistent volume that's taking the storage down from the CSI providers that do support. In this case, the Azure, as well as the GCPD. The next area that we're taking to beta with our latest release for 1.19 is Containerd. So why did we do Containerd? Like I mentioned earlier, please attend the other session on Windows because we do a deep dive on Containerd. But Containerd essentially allows us to align the direction of our investment with the rest of the Kubernetes community, as well as the other active investments that are happening across both the CRI community as well as the Kubernetes community. It's optimized and maintained by our community. That includes SIG-Windows, includes the Windows operating system team. You can see a huge consortium of contributors that are trying to get Containerd to work better. What are some of the benefits of that work? Number one is it's going to enable Hyper-V isolated containers to run on Kubernetes. That means that you're going to be able to have a secure multi-tenant boundary across Windows containers on Kubernetes. This is huge. It's going to enable a new class of use cases for the users where multi-tenancy is an important aspect of their delivery in their Kubernetes environment. And then what we don't have today is GMSA support, and we plan to add it. If you noticed earlier when I mentioned it, GMSA stands for Group Managed Service Accounts, and it enables Windows containers to carry a Windows Active Directory identity on the network. Today, it's not working for Containerd, but we're actively working to enable that. Let's take a look at the runtime architecture of Containerd at the high level. The previous architecture using Docker today, it works by having the kubelet with the embedded Docker shim all in one release, calling Docker, which in turn calls HCS version 1 schema, and then it goes down to the container. And HCS is a service that Microsoft started right when they delivered the first release of Windows containers called Host Compute Service. And that basically acts as an overlay or the boundary for connecting to the underlying container engine. With Containerd, the first thing that happened was it decoupled the Containerd effort from the kubelet. So now they can be versioned independently, they can be released independently, and it gives us a lot of flexibility here. And the CRI is embedded in Containerd in this architecture. And from there, it calls the HCS shim, which is basically a shim layer that was added in front of the HCS that enables you to make calls to both HCS or HNS, the host networking service as well. And now we support the V2 schema. With Docker, HCS V1 schema was the only one that was supported. The V2 schema was experimental, while in this case, it supports the V2 schema, allowing us to advance the vision of Windows containers and also support new critical update functionality like Hyper-V containers in the future. Looking at our technology matrix now. So what does that mean? When we started 1.14, our first release of GA for Windows containers, we only supported one operating system, and that was Windows Server 2019. and that was the LTSC release. That stands for Long-Term Servicing Channel. That's the release of Windows that's supported for many years, and Microsoft gives you an option to purchase an extended support agreement as well. Since then, we've made the decision as a SIG-Windows team that we're going to support one LTSC release and two SAC releases with every release of Kubernetes. SAC stands for Semi-Annual Channel Release, and that's a release that Microsoft ships twice a year and is supported for 18 months. With version 119, we're supporting Server 2019, our LTSC release, and then the two SAC releases, 1909 and 2004. 2004 is the latest and greatest release of Windows. If you want more information around the different servicing information and the different releases of Windows, there's a link at the bottom of this page that you can follow. Now, one of the last parts of 119 is some perf reliability improvements. We've heard from users that Windows containers need to execute better. We need to improve both the stability, reliability. We've heard your feedback, and we've done a lot of advancements in that area. The first advancement is in kubeproxy direct server return mode. Now we support DSR in Windows. That allows you to support scaling to a large number of services efficiently. Not only that, but also now we're supporting endpoint slices, so you can support services with a large number of endpoints. So not only can you support a large number of services, but now you can also support a large number of endpoints. If you're not familiar with endpoint slices, they kind of act as a source of truth for kubeproxy when it comes to how to route internal traffic in Kubernetes. So when you enable endpoint slices, you should see a performance improvement for services with this large number of endpoints, like I mentioned. Then additional performance beyond networking. Today, we gather a lot of the kubelet metrics through the metric server. So Prometheus can integrate with that. And some of those metrics time out when you have a large number of pods on Windows nodes. That's not great. That's not a great experience for our users. So now we've added support to make that better. So we'll have a much improved performance for the kubelet stats and summary work that we have. And we've also added support where CPU limits are now respected on Windows containers. So if a node is over provisioned, your limits are going to be respected. And more importantly, CPU limits are important because when you think of memory on a Windows container, there's no pod evictions due to memory pressure on Windows. So when things get processed to page, when they're paged to disk, then that means you get slow performance. So the way to bypass that is to use the kubelet reserve and the system reserve capabilities to basically allocate some of those resources for the node processes. So our goal here is to use limits, use reserves, and we're going to honor those in the scheduler with some of this work that we did. What's going on past 1.19 in our community? As you've seen from our roadmap earlier when I showed all the different releases, as a community, we keep investing in areas and we take them from alpha to beta to GA. And I've kind of segmented this area into three areas. The first one is compute. We're going to keep investing in Containerd. We're going to get that to GA. We're going to support Hyper-V isolated containers like I mentioned earlier. And we're also going to support GPUs on Windows. And that was something that barely missed the cut for 1.19. But rest assured, we're going to deliver it with 1.20. We're actually actively working on that right now. From a deployment and lifecycle management, kubeadm and Cluster API are the de facto ways to lifecycle management of Kubernetes clusters. And you want to get Windows supporting them to go to a stable, releasable state so that you can take advantage of Cluster API for provisioning, for first defining and then provisioning a Windows server containers and cluster nodes in Kubernetes. And from a storage standpoint, we're going to promote the CSI work to stable. We're going to add additional storage providers like vSphere and AWS. And we're going to light up Velero support so you can take advantage of CSI snapshots so you can back up and recover your cloud native applications running in Kubernetes. And in turn, we're also going to deprecate some of our in-tree storage plugins in lieu of the CSI support that we're adding. How can you contribute? Come join our weekly meetings every Tuesday at 12:30 Eastern. We have all our conversations are recorded. Come and help us write documentation, user stories. If you want to find some bugs to fix and engage with our community, we have a project board. Look for the bugs that are tagged as good first issue. Those are usually the ones with the minimal amount of knowledge that you need to know on Windows containers and Kubernetes to get started. And as you advance your involvement with our community, review open PRs, create your own PRs, can become a contributor or even a technical lead. We really are an open and welcoming community. And most importantly, we get to work on pretty much every area of Kubernetes. So if you get involved in Windows, you're going to touch storage, compute, networking, security, API. So if you want to learn Kubernetes end-to-end, SIG-Windows is one of the few SIGs where you can do that. If you want to reach us, on the left side, we have the two co-chairs, myself and Mark Rossetti, and Deep DeBroy, our technical lead. We have Slack and GitHub and how you can connect with us. And then as a SIG-Windows community, we're on Slack. We have a mailing list. We have our documentation over here. We have our GitHub Getting Started guide. So if you want to kind of have a one-stop shop for everything around Windows in Kubernetes. We have our YouTube playlist with pretty much every recorded meeting we've had going back 3+ years. And then our Zoom link for our meetings every Tuesday. Thank you all for attending this presentation. I'm going to open it up for Q&A now. Thank you so much.
Hello, everybody. How are you today?
Hi.
So Mark and I would like to thank you for attending our talk. Thank you for spending time with us, whether it's morning, afternoon, or evening, depending on the time zone where you are. We're going to start answering some of the questions that are on the Q&A right now. In addition to that, be aware that you can find us on Slack, and towards the end of this presentation, the engineer is going to post a message where it will be, but it's going to be on the CNCF Slack, and it's going to be under the 2-Kubicon-maintainer channel. And there's a thread for SIG-Windows and this meeting, and Mark and I are going to be there after this talk, so feel free to interact with us more. You can also find us on the SIG-Windows channel in Kubernetes. Like this slide has indicated, you can send us an email in our mailing list, or you can come to one of our community meetings. So there's lots of ways to engage with us. So let's get started answering some of these questions. All right, I'll start from the earlier one. So Mark answered the question, can there be Linux as well as Windows machines on the as worker nodes in the same clusters? Yes, that is correct. We support heterogeneous clusters where you can have multiple nodes. Be aware that the CNI that you use needs to be compatible with both Linux and Windows. So not all CNIs can support both operating systems, so be aware of that. Like, for example, OVS does, Calico does, Antrea does, but Flannel on the host gateway. Next question, how Kubernetes understands that this container has to be scheduled on Windows worker node. There's many ways that you can do that. Actually, in previous conversations in our documentation, we talk about a couple of critical ways that you can do that is by basically setting up the operating system in your YAML file to say targeted to Windows. We've also added a new variable that allows you to define the build of Windows that you want the scheduling to happen on, so you can define it there. You can also use the runtime class, which is what we recommend, so you can define it once and use it cluster-wide so that all of your deployments can basically target the runtime class, and the runtime class dictates where the scheduling needs to happen. And you can also use taints and tolerations, where you basically taint every Windows node with a specific, let's say you can call it Windows Server 2004, and then you have to add toleration on your pods in your YAML file to make sure that it lands on that node. Mark, anything else to add? I think I covered all of them. But
I was just going to say, if you're deploying kind of charts off Helm or other kind of deployments where you just kind of grab a pre-canned deployment, it is important to either look at the deployment or to add taints and tolerations to your nodes, because most kind of Helm charts that we've seen don't restrict the containers that must run on Linux to run on Linux. So it's just an easy way to help kind of protect yourself from kind of running into some scheduling issues in your clusters.
I absolutely agree. All right, the next question, how will CNI work on Windows machine? Will it work the same as the Linux machine? Fundamentally, the way the CNI will work will be pretty similar. It's going to have an agent or a pod or something running on the Windows node. It's going to connect with the master component of Kubernetes as well, so that it can actually connect to the API and know when new pods are being created, when networking, it needs to be networking components, IP addresses need to be allocated, or ingress needs to be set for some of these pods. But like I mentioned earlier, be aware that not all CNIs have a Windows implementation. The ones that we're more familiar with in our community are OVH, Flannel, and Antria, and not all versions of Flannel are at GA level.
Also, if you're interested, members of the Windows container networking team from Microsoft have delivered talks, deep dive talks into how container networking works at past KubeCons. So I would recommend looking up those videos on YouTube if you're interested in kind of looking under the hood a little bit.
Actually, David also published a blog post on understanding the state of container networking on Windows in Kubernetes. So let me see if I can find it really quickly here so I can post it on the answers as well. Mark, if you can answer the next question with the monitoring, I'll try to see if I can find the blog post.
Sure. The next question was, how are users monitoring Windows pods? Is metrics API reporting the same metrics granularity, and is it possible for Linux pods? The answer is mainly yes. So there was a lot of changes, as Michael mentioned in the talk, specifically around helping perf for the metrics APIs for Windows nodes. Most of the general metrics, especially those needed for operations like horizontal pod autoscaling, are the same as Linux. If you have kind of more specific questions on that, I'd recommend just reaching out in the Slack channel, because I don't have those answers off the top of my head, though. Okay, and the next question is, are there developments for a free open source option to use for network policies on Windows nodes? I'm actually not sure about that. Do you know about that, Michael?
One second. So Mark,
Okay.
I posted the link, the blog post that David created on understanding the state of networking. So yeah, I posted under the question under how CNI will work. If anybody's interested, they can read that. I want to add one more thing to your monitoring and metrics. We actually did improve a lot of the metrics APIs with 119. So folks are basically using Prometheus, for example, monitoring. They're going to see improved performance on how monitoring metrics are captured and reported. So both of those are great. Let me go to here. Are there developments for a free open source option to use network policies on Windows nodes? Yes, Antria actually, with the latest version 0.8, if I'm not mistaken, supports network policies. It is free. It is fully open source. If anybody's interested, they can go to that community. There are only two CNIs on Windows that support network policies. One is OVH, and the other one is Antria. Calico also supports network policies, but it's under the paid offering, the Calico Tagera Essential subscription.
All right. Thank you, Michael. The next question is it impossible for Windows to become master nodes in the future? At this point, I would say I think that most of the components required to run master nodes can technically run, but it hasn't really been a focus of the community today to get master nodes running, or Windows nodes running as master, simply because there's just so much work to kind of keep and maintain Windows nodes running as agents. And that's where kind of the community's focus has been. If this is something that you're particularly interested in, there's no reason why you wouldn't be able to join the community and help kind of move that agenda forward.
Yeah, and also one thing to add there is that the tremendous amount of testing effort that would have been required to actually convert from Linux to Windows and test everything all over again. And it's a non-trivial cost to us as a Kubernetes community. On top of that, there are certain assumptions that different components have made. Even though the language is portable, it's written in Go, there are some assumptions on the master components that are running on a Linux node, whether that's security assumptions or otherwise. It's just a huge effort. If any of our users or customers are interested in that, please be vocal about it so we can start collecting the evidence. But this is stands right now. This is not any need. We have zero goals around this. Rolf had a question about is Microsoft working with Red Hat to get Windows containers supported in OpenShift. I would like to please contact Microsoft privately about that. We can't speak on that from a community standpoint. Question number 9. How Microsoft licensing looks like in terms of using Windows Server cluster node and container images. Mark, yours. And do you want me to find the link on licensing as well to post it, Mark, while you talk?
Let's post the link. I'm not super familiar with this right now, or at least not in a way that I can talk about this. I think Microsoft posts all of their licensing terms online, and we just encourage you to read that and look at that.
Okay, I'll post that if you can take the next question.
Yeah, the next question is, are there migration tools to help migrate legacy apps to Windows containers? The answer to that is there are some. I know the Microsoft team has been working on a set of containers that they've all been made available on GitHub to help with things like logging. I know the way that Windows traditionally does logging is not very conducive for logging in containers or in container orchestration platforms. And so there are a set of tools that you can install and will listen to things like your ETW events and publish them as text logs, which you can use other kind of container monitoring solutions to look at that or to get those out. Are you aware of any other ones, Michael?
No, I'm not aware of anything else.
Yeah, let me find a link and post that too.
Okay. I'll take the next question. We're having Kubernetes cluster on VMware. If we have Windows as worker node, then CPI and CNS of VMware will work for Windows worker node. Not everything will work. I want to be a little bit clear there. vSphere volume will work from a storage standpoint for persistent volumes. Then from a compute standpoint, obviously, it will work. But CSI and the new work that we're doing in SIG-Windows with the CSI beta that's coming out in 1.19, that will not work on VMware yet. We're working to enable that, so there are some caveats there. CSI will not work, and vSphere volume is the only persistent volume you can use. Any other questions? We have about 2 minutes or 1 minute left in our session. If there's any additional questions, ask them here or come find us on Slack. Find us in our community meetings. We have lots of ways to engage. This has been a very lively discussion. We saw 125 of you that joined today. Thank you so much. Is GitOps such as Argo CD possible at this time? A lot of the GitOps and CI/CD tools today use the Kubernetes API to connect with Kubernetes and enable the CI/CD pipelines. Windows containers don't have any difference from a pipeline standpoint. We use the same Kubernetes APIs. You can target the same artifacts on Kubernetes for Windows as you can do on Linux. So there is no reason why GitOps wouldn't work as long as they target the Kubernetes API, and you should be able to connect those and leverage publishing Windows containers and Windows apps on Kubernetes. The next question, the last question here, what are some tips or best practices for migrating legacy applications to containers? I'm going to do a shameful plug here, but at VMworld, both US and Europe of last year, 2019, if you go and connect, you should be able to, for free, download. I did a presentation. If you search for my name, Michael, you find it on some best practices for migrating legacy applications to containers. It's a 1 hour long presentation. I talk about the caveats, some things that may work, some things that may not work. It's a fairly involved conversation. Maybe given these questions, might be worthwhile for us to actually do a presentation like that in the next KubeCon. So Mark and I will take that under advisement. But please go to VMworld, look at 2019, find my presentation. It's a 1 hour long, has lots of good content in there, or come to one of our community meetings and we can chat more. But it's a big topic. All right, folks, thank you. And come and find us on Slack for additional questions.
Yep, thank you.